everybody. I think we can start the session. So let me just give you a very brief introduction about myself, and I'm Pietro, that is co-host with me today. So I'm Giovanni Rossi. I'm the head of marketing and communication at ELECTRA AI. I've been working for 14 years, across marketing, communication, and growth at the intersection of energy and technology, helping companies scale internationally and build sustainable business model. Starting consultancy and then focusing on energy business model for the US, Europe, the Arab Gulf, and India. I joined some multi-utilities, public listed groups, and then, brought into the startup world. A couple of years ago, I joined ELECTRA AI, where we turn advanced battery AI into market traction. Pietro, if you want to give a brief introduction about yourself.
Yes, of course. Thank you very much, Giovanni. My name is Pietro Mosca. I'm currently Director of Advanced Engineering here at ELECTRA AI. I have a lot of experience when it comes to optimal control, machine learning, and also lastly also blockchain in different sectors, so from the automotive to the energy sector. I have extensive experience also serving in different markets around Europe, Japan, and the US. Thank you very much. If you're speaking, Giovanni, we are not hearing you.
Okay, sorry. Yeah, so I'm gonna start again. So I was saying that, I'm going to say something that you may already know about, the importance of batteries that is related to, how the rise of renewable energy is transforming industries worldwide. We have solar, wind, we have, new and other sources right now that are at the center of the global energy transition. But the biggest problem that still remains, that, the sun doesn't always shine and the wind doesn't always blow. And so you need batteries to meet and store the excess of energy when it's available, and then delivering it when it's needed the most. But one of the biggest challenges that remain with battery is like almost every battery on Earth is operating blind right now. Let me move this. Okay. So we have that the battery management system running the batteries are designed to keep cells safe, not to understand them. They can tell you with precision how healthy a battery really is, how much life is left, or when something is about to go wrong. So you're flying a multi-million-dollar asset, basically with almost no instrument or with basic instrument. And that blindness has a cost. First, the biggest one is like, maintenance and faults that can increase the cost up to 30%, impacting safety and reliability. The second one is unmanaged degradation, then can decrease the lifespan of the battery up to 5 years. And third, you have like, poor asset and energy management strategy that can cause a 50% drop in return on assets. And when blindness fails at the extreme, you have like, catastrophic events. Moss Landing in California, that is like the world's largest battery plant that got on fire. The situation in South Korea that paralyzed government services, McKinney in Arizona, and so on and so forth. These are not obscure events. It's interesting to notice that even if they are pretty rare, when they happen, they are pretty catastrophic. They impact safety, of course, reliability of government, of environmental situation, but also millions or billions in certain case of dollars are lost in this situation. And how the industries as of now has always replied with more batteries, more assets, instead of like working on different aspects. So more redundancy, more overcapacity, more steel. But this was always the wrong answer, because you don't solve blindness by buying more eyes you can't use. So that's why at ELECTRA, we have developed the most advanced AI-powered brain for batteries. So with battery fit analytics, and this is like the two products that we have, operators can monitor and optimize a battery portfolio at scale in the cloud. And with adaptive controls, our embedded solution, operators can enable AI-driven BMS with technology embedded at the edge. Our brain is based on 20 patents, around 1.5 billion data points altogether, and thousands of parameters, to monitor, manage, and optimize battery assets. And here, is how to think about where we sit. Below it is the hardware layer, and a control layer. On top, of course, you have the BMS, where it's like the input layers, and on top of that, you have where Electra sits with the AI battery intelligence layers that is providing the right informations and right estimation and predictions of state of health, state of charge, state of power, remaining useful life, predictive analytics, and so on and so forth. All of these can help you, minimize downtime, predict faults, extend the battery life, enhance safety and reliability, and at the end of the day, maximize, of course, the battery ROI while also being compliant with the new regulations, such as the battery passport in the European Union and all of the additional regulation on this field that require digital record for every battery, since the material was sourced until, of course, the estimation of the states and key performance indicators of the battery, and then, of course, the recycling in that. So we just saw where we sit. And on top of the stack, as the intelligence layer. Now, let me show you what that position is a new generation, not a faster version of the old one. Battery intelligence has moved through three main generations. The first one was protection, passive BMS, watching voltage, current, and temperature, and keeping, of course, as I mentioned, the cell safe, and doing nothing less or nothing else, nothing more than that. The second one was digital one with estimation, column counting, lookup tables, calibrators, at the beginning and not change during, of course, the life of the asset. The third one is where we have the most advanced system on the market today. That is the modeling with Kalman filters and equivalent circuit modeling and so on and so forth. And then you have the first generation that is AI driven, there where is Electra sits, that is fusing physics and AI, so chemistry's information, physics information about the batteries and everything that is happening within the asset. And on top of that, you have also the machine learning and the AI capabilities that are managing a large amount of data, field data, lab data, and also cost industry data to predict, estimate, and perform and optimize better the asset, either in the cloud and then also in the real world application. And what's the value of the brain for batteries? Well, in real world case studies, we have seen that you can achieve 30% battery life extension and 20% extension of range in case of EV fleets, as you can see here. And if, of course, this means to save up to $1,000 on a 15,000 miles, according, of course, to the specific vehicles. We demonstrated this with a Tesla Cybertruck. In the case of stationary storage application, you can save up, and then we're going to see more details with Pietro, the ROI per battery, so you can optimize the capacity of the batteries, the energy of the battery, and so, of course, doing much more with your asset, and so having a 15% ROI in addition to the current ROI that you have per year, that results in the total life of the batteries, in this case application, that we have in 143% more in the full lifespan of the battery, and increased percent also 40% increase in uptime. And then also in terms of accuracy, we've seen that we have less than 1% error in estimated change of charge in state of health against the industry standard between 5 to 25%. And less than 5% in state of power, against industry standard of 9 to 15%. So it's pretty, remarkable in terms of results. And our technology is chemistry and hardware agnostic and can be adaptable across multiple verticals, from stationary storage application for grid, renewables, and data centers to e-mobility and robotics. The principle, is the same. Whatever is a battery, there can be Electra brain, and our algorithm learn from each other. So if it is a best application for data centers, it learns something that can be used in another use case, because at the end of the day, the batteries is can be in a similar chemistry, in a similar format can be very similar and a learning curve, a learning path that can be reused. And so, of course, the more we get, the better, and the more we can scale across different applications. In terms of market, is it's a pretty large market, so it's growing into different mission critical, of course, segments. You have data centers and AI infrastructure with CAGR of like 19%, robotics 16%, satellite 15%, and energy storage 14%. But we focus mainly on like the mission critical target market. That is a market of like 19.1 billion out of 71% of the total market. That is where uptime, safety, and performance can directly impact the ROI. And we are like focusing mainly on this segment of the market, because of course it's the most compelling one for our technology, and is where of course our AI brain can deliver the maximum value. And in order, to bring our AI brain everywhere, we have recently announced, our business combination agreement with Iron Horse Acquisition Corporations, as we are going public in the second half of 2026, becoming the first AI battery intelligence company listed on Nasdaq. So this is like, a very important milestone for us, and we are like, going toward this public path. Something quick about Electra. Electra was founded in Boston in 2015 by Fabrizio Martini, our CEO and co-founder, after working at NASA on project for optimizing batteries for space explorations. We are considered a NASA spin-off company. We are also part of the NVIDIA Inception program and, of course, Volta Foundations. We operate across United States, Europe, India, and Korea. And here you have also like a snapshot of our leadership team. In terms of like capabilities, we have around 1 gigawatt hour of batteries under management today and a pipeline of more than 5 terawatt hours. We don't build alone. We have many different technical partners, including AWS, NXP, Texas Instrument, Goodyear, MATLAB, and many others. And also we are backed by strategic investors, including Stellantis, BlackBerry, Ferrari Family Investment, and United Ventures, and more to come. Last but not least, our three main differentiator is, and is important, as a take for today, that it is like, our three main advantages that we like that is helping us, into going also in this public path and in growing pretty fast. That is like a compounding data mode. So our models are trained, across industries and across verticals with years of deployment. So they keep continuously, continuously. These create an intelligence layer that no single ecosystem can match. And we see this because majority of the competitors that we have are like focusing mainly on one verticals, while we are like chemistry and hardware agnostic. And so being into this situation, we can complement our technology and can an independent provider for everybody, and so to provide this intelligence to everybody. Second, as I just mentioned, our hardware and chemistry agnostic. So we have worked a lot to build models and algorithms and all the infrastructure to runs independently of any single architecture or cell chemistries, and covering as of now 95% of them, and so removing any blockers from the customers. And third, as already mentioned, we have physics plus AI. We fuse, first principle electrochemical models with machine learning, and so to be more precise, more predictive than ever, and deliver as much ROI as possible according to the specific use case of each customers. We are also back from like industry and university advisor from Stanford, Columbia, University of Washington, West Virginia University, and Rockefeller, that supporting us all along the way to improve our models, our capabilities, and our strategic product strategy, and our deployment into different applications. And now I leave it to Pietro to tell you a little bit more about our technology in terms of technical terms. Thank you very much.
Thank you very much, Giovanni. So welcome to the more technical part of the presentation. So this part is going to be dedicated to one of our products, which is battery fleet analytics. Let me proceed by sharing my screen. Okay. I should be able to see my screen. So this product is a product that we use to monitor batteries which are deployed in the field. Specifically, we operate across different sectors, from mobility to also stationary storage applications such as BSS. So the use case, the advancements in the AI, let's say, we started seeing, for example, the construction of new data centers, more bigger and bigger, let's say, requiring and stressing, let's say, the current power network. So specifically, we see that we need for the new LLM models, for example, high density GPU racks, which in turn they can, for example, stress the network on periods of high load. So in order to keep these services, keep this hardware running, people starting using BSS, bigger containers hosting batteries to, let's say, guarantee continuous operation of these data centers. Due to, for example, in order to provide power in case of failure of the network, in case of, for example, high demand, and critical loads, let's say. So these batteries before, they were completely, let's say, not controlled, or the visibility was limited. We actually, with our AI layer, we provide, for example, advanced analytics on the state of the battery. We provide early fault detection, for example, as well as also more accurate, let's say, management of the battery due to the more accurate estimation of the states. And also we provide recommendation how to optimize the control of the batteries. So these, all this kind of intelligence layer, which sits on the top, let's say, of the BMS or EMS, impacts the operation of the battery, guaranteeing a more long lifespan, for example, and as a consequence also important economical advantages. If we talk about, for example, a return of investments, due to the longer lifespan, let's say, and also less downtime for the battery, so guaranteeing that the battery is operational most of the time. So our product, Battery Fleet Analytics, in fact, help this process by providing additional visibility on the asset. For example, we are able to provide you with information very accurate on state of charge, state of health, and remains life. We are able to extend also the battery lifetime by providing recommendation on the usage of the battery, specific on the use case that we are considering. And also we provide a service to also detect in advance faults and say, problems that can occur during the operation of the battery in order to facilitate predictive maintenance and enable lower downtime and higher, let's say, operation time. The products that we have for this specific use case are two. The first one is the Battery Fleet Analytics. Is a pure cloud platform that is used to monitor the batteries which are deployed in the field by ingesting large amount of data and automatically process this data and provide insights and analytics directly to the operators of the batteries. The second one is what we call adaptive controls embedded SVXC. Is an algorithm which sits in the BMS and predicts, actually estimates in real time with a very high accuracy. Giovanni was studying before about 1% state of charge, 2% SOH, and 5% state of power in real time for FP batteries. So very impressive results. So sits in the BMS and operates in real time to provide the BMS with a very accurate reading of the states of the battery. Today we are going to focus on the battery fleet analytics. How does it work? So specifically, we have, for example, containers which are deployed in the field. These containers are collecting data through their BMS or EMS and sending data most likely to some kind of local server. So you might have already some kind of SCADA system which is providing information on the status of the plant. What we do with our product is that we are able to pull this data in our cloud, run an automated data ingestion and a pipeline to basically clean the data, which are coming from the field. So it's not always a easy and trivial operation. Get data that can be actually used for something. We apply some feature engineering to extract meaningful information from the data. And through our PhD and ML models and algorithms are able to actually extract insights, are able to extract important metrics that are useful for the control and the monitoring of the batteries. So all these metrics are actually available through our UI in case, but also through API. So this API can be very easily used to integrate our product with the SCADA system that you guys are already using. So here I'm going to introduce you to some of the business cases that we have based on our experience. So the first one is a specific one for the BSS. Specifically, we collaborated with Flux Solar to monitor their plants, and what we see is that we are able to increase the uptime of the plant, specifically with also important increase in the return of investment due to the let's say prolongation of the life of the battery. So in fact, due to our recommendation on the utilization of the asset, we are able to prolong the useful life of the asset, and in this case also the return of investment. We are going to see also later how this is achieved. So in let's say we are able to perform this throughout let's say an increase in effective utilization of the asset, which in turn allows the manager to squeeze all the possible value out of the asset. The other use case and business case that I'm gonna bring today is with the one with Yuma. Specifically, Yuma is let's say a mobility provider in the Indian market of two-wheelers, for example, and the swappable batteries. So in this case, we are able, for example, to provide a very accurate estimation of the state of health of the asset that we were monitoring. And these allow to, for example, save a lot of time and money in periodic, for example, diagnostic tests, which are not scalable, especially if the battery are a lot. In this case, when we talk about thousands of different batteries. And also, a better estimation of the state of health and the residual, let's say, energy which is in the battery allows to optimize also the operation of the batteries, providing, let's say, a higher revenue per battery. So, and this we computed let's say the final advantage, which is around $45,000 for 1,000 batteries. So this also was a very good use case. The next step, as next, I'm gonna introduce you to a short demo of our platform. So let me change the screen. I hope you guys can see my screen. Joe, can you see? Okay, perfect. So this is a demo of our platform. This is the homepage of it. So in this case, we are actually showing you 5 assets that we are currently monitoring. These assets correspond to around 340 kilowatt hours of energy. So these are specifically BSS. So this is the kind of use case that we are seeing. At the first glance, you can see how what is currently the battery health for it, and how many cycles we measure, for example, equivalent full cycles. We can also see in a graph way how the state of health corresponds to the different cycles. But let's say we want to get a bit more information about one of these assets. So we can select, or we can actually select multiples, but we can select just this one for the sake of the demonstration. So this asset is around 69 kilowatt hours of let's say energy. You can see at a glance what is the state of this asset. So it sits at around 95% state of health. And you can see from this graph, for example, how the asset degraded over time. So we can see here, based on the cycle at which the asset is, the trajectory of degradation, as well as the predicted SOH trajectory over time. So with also some kind of confidence intervals, this is gonna tell you, for example, how much the asset is gonna last before it reaches around 80% state of health. So we estimate in this case a remaining useful life of 1,472 cycles. So these important metrics are computed based on, let's say, physics, but also based on machine learning models, especially the prediction of the state of health trajectory. Together with that, we also, for example, provide statistical information on the operation of the battery. So in this case, you can see this asset was used for peak shaving. So it was connected to a solar plant. In this case, you can see that actually the asset stays most of the time, for example, in this case, as you can see from this graph, at around 90 to 100% state of health, state of charge, which is actually not desirable, it's not optimal, because we saw, from laboratory experimentations, but also from the practice, how this contributes to, let's say, a more rapid deterioration of the asset. Is being, let's say, you can see also how the asset is being charged, for example, what are the voltage levels of this asset, as well as the distribution, for example, of the temperature. So you can see in this case the HVAC is performing pretty well, keeping the battery between, for example, 15 and 30 degrees. We also provide you with some information about the utilization of the asset. So as I said before, this asset was using for peak shaving. So you can see actually a very regular span over the day. So this in x-axis, you see the time of the day in which the state of charge was decreasing. So it was relatively low respect to other times of the day. So in this case, it was around 50%. So the battery was depleted around 50%, but you can see that most of the time, most of the day was kept very charged, let's say between 95 and 100%, and is kind of not desirable. So you can see actually and optimize the operation of the asset with our recommendations. So what we provide is also AI-based recommendations. So we used actually PhD level, let's say very specialized large language models in order to also perform some kind of analysis of the data, of the pattern of utilization, and provide the user, which not always, let's say, is very expert in battery science, some tips in order to improve the utilization of the battery. So in this case, we were noticing that the battery was always kept a very high state of charge. So in this case, we were suggesting the user to, let's say, reduce the operating voltage and also reduce the average operation state of charge, and this to contribute to a longer lifespan, for example. Okay, so I'll go back to the presentation. I think it's, let's say, question time, if someone has any questions.